Think you know what a real explosion looks like? You might have seen explosions in movies or on TV, but those are often dramatized for effect. Real-life explosions, especially those involving hazardous materials like LPG, are far more intense and dangerous. They can cause widespread damage, injuries, and even fatalities. So what exactly happens when an LPG tanker goes boom? Let's dive into the science behind these catastrophic events. Think again. Let's break it down. Understanding the mechanics of an LPG explosion can help us appreciate the safety measures in place and the importance of adhering to regulations. It's not just about the dramatic visuals, it's about the underlying physics and chemistry that make these explosions so powerful. LPG, or liquefied petroleum gas, is stored under high pressure. This is because LPG is a gas at room temperature and pressure, but it can be liquefied under higher pressures, making it easier to transport and store. The high pressure keeps the gas in a liquid state, which is much denser than its gaseous form. This allows for more efficient storage and transportation, but it also introduces significant risks. Picture this: a soda can. It's a simple analogy, but it helps illustrate the concept of pressure containment. When you shake a soda can, the carbon dioxide gas dissolved in the liquid creates pressure inside the can. This pressure is contained by the can's walls, just like the pressure inside an LPG tanker is contained by its metal walls. Shake it up, and what happens when you pop the top? The pressure is suddenly released, causing the soda to fizz and spray everywhere. This is a small-scale example of what happens when the pressure inside an LPG tanker is suddenly released. The difference is that instead of harmless soda, we're dealing with highly flammable gas. That release of pressure is a tiny version of what happens inside an LPG tanker. When the pressure inside the tanker is suddenly released, the liquid LPG rapidly turns back into gas, expanding to many times its original volume. This rapid expansion can cause the tanker to rupture, releasing a large amount of flammable gas into the surrounding area. Now imagine that soda can is the size of a small building, and instead of harmless soda, it's filled with highly flammable gas. The scale of the potential disaster becomes much more apparent. The amount of energy released in such an explosion can be enormous, causing widespread damage and posing a serious threat to anyone nearby. And instead of harmless soda, it's filled with highly flammable gas. LPG is a mixture of propane and butane, both of which are highly flammable. When released into the air, they can form explosive mixtures with oxygen. This is why LPG tankers are marked with hazardous material warning signs and are subject to strict safety regulations. If the tanker gets damaged or overheats, the pressure inside can skyrocket. This can happen for a variety of reasons, such as a collision, a fire, or even prolonged exposure to high temperatures. When the pressure inside the tanker exceeds the strength of its walls, the tanker can rupture, releasing a large amount of flammable gas. Eventually it hits a breaking point. The metal walls of the tanker can only withstand so much pressure before they start to fail. Stress fractures can form, and once the integrity of the tank is compromised, a catastrophic failure becomes inevitable. The pressure gauge reaching its limit is a clear indicator that the situation is becoming critical. When that happens, the gas rapidly expands, mixing with air and ignites. The ignition can be caused by a spark, a flame, or even the heat generated by the rapid expansion of the gas. Once ignited, the gas burns rapidly, creating a massive fireball and generating shock waves that can cause further damage. This creates a massive fireball, shock waves, and can cause serious damage. The fireball can reach temperatures of several thousand degrees, incinerating anything in its path. The shock waves can shatter windows, knock down walls, and cause injuries to people even at a considerable distance from the explosion. But don't worry, there's a lot of science and safety measures in place to prevent this from happening. Engineers and safety experts have developed a range of technologies and procedures to minimize the risk of an LPG explosion. These include regular inspections, maintenance, and the use of advanced materials and designs to make tankers more resilient. Tanker designs include safety valves and thicker walls to withstand pressure. Safety valves are designed to release pressure gradually, preventing a sudden rupture. The walls of the tanker are made from reinforced materials that can withstand higher pressures and temperatures, reducing the risk of a catastrophic failure. Plus, emergency response teams are trained to handle such incidents. Firefighters and hazardous materials teams undergo specialized training to deal with LPG tanker accidents. They know how to contain leaks, extinguish fires, and evacuate people from the danger zone. Their quick and effective response can make a significant difference in preventing a disaster. So while the risks are real, the chances of an explosion are minimized by strict regulations and advanced technology. Regulatory agencies enforce stringent safety standards and companies invest in the latest technology to monitor and control the conditions inside LPG tankers. This combination of regulation and innovation helps keep us safe. Stay informed, stay safe, and remember, knowledge is power. Understanding the risks and the safety measures in place can help you stay calm and make informed decisions in the event of an emergency. Always follow safety guidelines and stay aware of your surroundings when near LPG tankers. Until next time, stay curious. Keep exploring and learning about the world around you. There's always more to discover, and knowledge is the key to staying safe and making informed choices.